All right, welcome back, everybody. It is time for week number 2 of e-learning. Hopefully, you kind of took some time over the weekend and didn't have to do much with school and were able to kind of take a break because you got your work done during the week and then you got to have Saturday and Sunday off and just chill. Although, if you're like me at all, I'm getting a little bored of just sitting and chilling. So it would be nice to be able to get out and do something, but we're going to do the right thing. So we'll stay in and find new things to do, new shows to watch. Hopefully if you're stuck on the TV or something, you're watching something educational. I just went and pulled my son off of the YouTube video he was watching and made him go to National Geographic. So don't let your brains melt. Find something interesting and educational to do with your time if you got to be stuck at home, right? Okay, anyways, we're going to get started today with notes number 4. We're going to talk about series, which is an extension of what we were doing last week. Last week we talked about sequences, arithmetic and geometric sequences. And basically all we're going to do today is we're going to take all of the terms of a sequence and add them together. And when you do that, that is called a series. Okay, so let's kind of go through some vocab here just to kind of see what all these different things are and understand what these words mean. So some different types of sequences and series. If I have a finite sequence, right? The word finite means that it has an end, right? It has boundaries, so it has an end. So a finite sequence would be something if I did like 1, 2, 3, 4, 5, right? So my sequence starts with 1 and it ends with 5. It has an end. A finite series, I'm just going to take those same terms and I'm going to add them all together. So 1 plus 2 plus 3 plus 4 plus 5. Now it's a series because we're adding all those terms together. Okay, we can also have a sequence or a series that is infinite, and we'll get to this a little bit after spring break. But an infinite sequence just means it doesn't end, it goes on forever. So I would write it as 1, 2, 3, 4, 5, but then I'll put another comma and a dot, dot, dot. And that just means that the sequence keeps going and it never stops. It just keeps going in that same pattern. Same thing with a series. I would do 1 plus 2 plus 3 plus 4 plus 5. And then to show that it keeps going, we do another plus sign and then a dot, dot, dot. So again, it follows the same pattern, but this time we're adding all the terms. All right, and then a quick reminder, remember we talked last week about arithmetic and geometric series, or sequences, where they have a certain pattern. Arithmetic, you're adding something, you're adding the same number to get the next term each time. Geometric sequences, you're multiplying by a number to get the next term in the sequence. An arithmetic series or a geometric series, again, has the same exact pattern, it's just that we're adding all the terms together. So an arithmetic series, I could do 3 plus 5 plus 7 plus 9 plus 11, right? It's arithmetic to get from 3 to 5, I add 2, from 5 to 7, I add 2, 7 to 9, I add 2, and so on. So it's the same pattern, but this time I'm just adding them all together. Same thing with geometric. If I did 2 plus 4 plus 8 plus 16, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we've got a geometric pattern there, but we're adding those all together for a series, right? So the big difference this week is we're going to talk about series, where we add all the terms together. Okay, so when we talk about series in math, there's a very important symbol that we will use a lot in this stuff. Oh, come on, stupid screen. Sorry. Okay, very important symbol that we'll use. It's called a sigma, or a summation sign. So we use the Greek letter sigma, that's a capital S in the Greek alphabet, and that sigma always stands for a summation sign. So anytime you see this sigma guy used in math, that always think about adding. That's a sum, right? So we're always going to sum what we see. All right, here's what all the different parts of that symbol mean. Okay, so the summed, that word, that is what you're adding up. So in our example up there, the summed would be the n squared, right? That's what that part is. And basically the summed is kind of like the formula. It's going to be the formula that gives you all of the terms that are in the series. The index, right? The index up in this example is in, right? And you can always tell what the index is by looking right there. That's how I can tell what the index is. It'll tell me what the variable is. And basically that is our counting variable, right? This is what tells us how we're going to move and get the next terms. And then lastly, the limits of the summation. The limits are what tell you where to start and stop, right? Where do I start adding? And then where do I end? So what term do I start at? What term do I end with? That has an upper limit and a lower limit. So in the example that we see up there, the upper limit would equal 10. That's this guy up here. And then the lower limit would equal 1. That's that guy there, right? So that's how we get all the different parts of what's on the summation sign. Okay, so now let's see how this actually works. Let's take a summation and actually write it out and find the sum that it wants us to find, right? So this summation sign is telling us that it wants us to start where I equals 2. It wants us to go to where I equals 6, right? So this is our start. This is our end. And then that means that I is our counting variable, and that's where we see it up in the formula. So our sum end there, what we want to add together is the 3i plus 1, right? So basically, you're going to write out each term of this series and then add them all together. Okay, so our formula there is that 3i plus 1, right? So my first term, remember, I'm going to start with 2. So I want to do 3 times 2 plus 1. That is your first term in the series. Right? I started with 2. Okay, so then I'm just going to increment up until I get to 6. So then I would add the next term, which would be 3 times 3 plus 1. Our next term would be 3 times 4 plus 1. Oops. And our next one would be 3 times 5 plus 1. And finally, 3 times 6 plus 1. Keep making the wrong parenthesis. There we go. Okay, so I started, right? I started where I is 2. I went up by 1 each time, so 3, 4, 5, and then I stopped when I got to 6. So this is a finite series, right? It has a start point and an end point. So then if I just work out all of those numbers, well, that's 3 times 2 plus 1, that's 6 plus 1, so this would be 7. Next one is 9 plus 1, so 10. Next one is 12 plus 1, so that would be 13. Then 15 plus 1 is 16, and 18 plus 1 is 19. You can kind of see the pattern there too. It's an add 3 each time, right? And then if we do 7 plus 10 plus 13 plus 16 plus 19 and add those all together, we get a sum of 65. Right? So when you see a problem that looks like this guy, right? When it looks like that sum thing and it has a formula, that's asking you for what is the actual sum. You have to add something together to get that answer. Okay. All right, let's try something a little bit different here. So notice the directions on the problem we just did. It said, write the following series in expanded form and evaluate, right? It had 2 different instructions. So writing it in extended form or an expanded form, that's what we did right there, right? We wrote out all the different terms. And then the evaluate means actually find what that sum is. So that's why there's 2 different directions there, right? Now the next one, notice that the directions just say, write it in expanded form, right? So I don't have to evaluate this one. I don't actually have to find the sum. I'm just going to write it in extended form. There's kind of a reason that's the directions on this one. Okay, so this time we're going to start where j equals 1. And then there's our j that we're going to replace with the number each time. But we have 2 j's this time, right? So an exponent, we got to plug it in there, and we have to plug it in there in part of our term there. Okay, so to write out the first term, I'm going to do -1 to the j. So our first j is to the first power. And then j plus 2. So 1 plus 2. And there's my first term, right? Okay, then my next term would be -1 So I'm going to increment up 1 to the second power, and then j plus 2, so 2 plus 2. Right, there's our second term. Okay, then comes my third term, negative 1 to the third power, and then this would be 3 plus 2. Okay, now I'm going to see a problem here. Hopefully you've noticed it by now. Like this told us to start at 1. Look at where it tells us to stop. 20. That's a lot of terms to write out, right? So a lot of times you'll see this is a finite sequence or a series again because it has a start and stop point. But I don't need to write out all 20 terms if I want to write it in expanded form. That's a lot of terms to write out. So I'm going to do the first 3, and then I can put a plus and a dot, dot, dot to show there's a whole bunch of other terms in there following that exact same pattern. And then we just have to write the last term because the last term tells us, okay, this is where I'd stop, right? So that's what I've got to write an expanded form. So I have to show the start and the stop, but I can skip a whole bunch in the middle. Okay, so make my bracket. In the last term, I'd go negative 1. The last last j I'm going to use is 20. And then 20 plus 2. Yeah, last term. Ta-da! Kind of like when you're a kid and you first learn like that 1, 2, skip a few, 99, 100. My kids just started doing that, right? So you're writing the first few terms, skipping a whole bunch in the middle, and then saying the very last one. Okay, so then we can actually simplify these. We can work them out, right? So this first one, we would do negative 1 to the first power. That's negative 1. 1 plus 2 is 3, so 3 times negative 1 would give us negative 3. Right? That'd be negative 1 times 3. Next one, negative 1 squared. Well, that'd be a positive 1 times 2 plus 2 is 4. So that would give us 4. Negative 1 to the third is a negative 1. 3 plus 2 is 5. That would go to 5, or negative 5, sorry. And then our last one, negative 1 to the 20th power. Well, that's to an even power, so that's going to be a positive 1. And then 20 plus 2 is 22. That'd be 22, right? And then we put our plus signs in here, so I didn't put them in there yet. And again, just a dot, dot, dot to show that we've got some terms we're not writing in, and we've got the last one. So that is your expanded form of that series, right? So my kind of rule of thumb is if there's more than, I don't know, more than 6 maybe terms, then just write it like this. Write the first 3, do your plus, your dot, 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 your plus, and then your last term. Okay, if it's a bigger number, you can just write it out like that. Okay, next one, same idea, right? We want to write the series in expanded form. So again, no evaluating here. I don't have to actually get an answer, but I'm just going to write it out. Okay, and this time notice that when I look at my summons, the things I'm adding up here, there's 2 variables there, right? So the n is going to get replaced with our numbers, right? Our start and stop numbers, but the x is just going to stay an x. So this one isn't exactly a number answer. We have some algebra going on in this one, but again, start with the same thing. So this says to start where n equals 3. So my first term I'm going to write, it's nx to the n. So I'm going to put 3 x to the third, right? Then I go to 4. So replace the n's with 4s. So 4x to the 4 plus, replace the n's with 5s. So 5x to the 5th plus, replace the n's with 6s. 6x to the 6th. And then the last term is 7, right? So 7x to the 7th. And then I can look at 3x cubed. I'm adding all those. None of those are like terms. So I can't actually all add them together. If I could simplify this down and add those together. But that is the simplest version of that sum that I can write out. Right? Okay, so series, right? Series is basically just taking a sequence and adding them all together. We won't do a whole lot of problems today on your homework that look like these last 2. I take that back. There's a couple like example 8. But more often, you're going to find yourself actually evaluating the sum. So write out all of your terms, right? And then just add all those numbers together once you've got them. Okay. All right. Your homework today is on delta math. We've done this before, but I'm going to try to switch to that because I think it will make homework a little bit easier. You don't have to upload it to OneNote that way, kind of kill some of those headaches and make this a little bit easier to do while we're doing e-learning. So Your login for your Delta Math should still be your Brebeuf login. Hopefully that's the way that you set it up at the beginning of the year. If anybody doesn't have a Delta Math account for some reason, please let me know as soon as possible. Send me a message on Google Chat or email me, and I will make sure you get added. Okay. If you have any questions, please let me know. And hopefully this week goes well like it did last week, or it goes better if you did not have a good week last week. See you guys soon.